Hi everyone, so we are back yet again with Piecewise functions, and this time we're going to be talking about a word problem, a context. And so let's just get to it, shall we? I have a context that you guys will probably laugh at, but get over it. Be kind, don't laugh at me. It's a little outdated. Some of these contexts are sillier than others, but hey, they work, they serve a purpose. Okay, so back before Lyft and Uber, all my young bucks out there were these things called cabs. Yeah, taxis. And many of them had a flat rate when you first kind of hopped in the cab, so to speak. Even if you only had to go 2 blocks, you were still going to pay a certain fee. But then after that, there was typically a mileage rate. And a lot of times, depending on how far you had to drive, the mileage rate was kind of like prorated, like it would change. So that's what this context is about. So again, bear with me if it's a little bit unrealistic for the year 2020, but it'll still serve the purpose that we needed to serve. Okay, so we have a taxi service in Kansas City that charges a flat rate of $3 for the first mile. And then after that, they charge $1.50 per mile for each successive mile. And that, friends, is the rate up to and including the 15-mile mark. However, if you need the cab for more than 15 miles, well, then the rate changes again. This time it drops to $1 per mile, up to and including this particular cab. Let's assume that it only goes a maximum distance of 40 miles. So those are the constraints of the problem, and we will simply take them one piece at a time. Okay, so here we go. First of all, the first piece, I've outlined it in purple. For the entire first mile, it's simply $3. So the cost of a cab ride with this particular company, if you only need them for a mile, it's just going to be $3. So the cost is a function of miles, and the first piece, not $3 per mile. No, just $3. $3. Not 3 times M, no linear functions here. It's just $3 flat. And that would only be true. You would only be paying $3 exactly if you only needed the cab for a mile. So between 0 and 1 miles, it'll just be $3 and that's it, period. Now, if you need it for more than that, of course, though, that's when they start to charge you per mile. So notice now I'm going to get into the second piece. I guess I could have switched colors. I apologize. That would have been more pleasing to my visual learners in the room, huh? So I'll switch to pink. So the second piece is the fact that after you've driven your first mile, the rate then changes to $1.50 per mile. Now, here's the thing though, $1.50 per mile, but you're not going to be charged $1.50 per mile for the first mile you drove. No, you are not. Only for the miles after that. So that particular rate does not even exist until you've already traveled a mile in distance. Think about if it was a 5-mile cab ride. If it was a 5-mile cab ride, only 4 of those miles would be charged at this rate. The other mile was just a $3 flat fee. So that mileage does not kick in until 1 mile later. Transformation of functions, y'all. Okay. I mean, just picture it with me. Here's the 1 mile mark. It is at that tick mark right there that the slope of $1.50 per mile would kick in. 1 tick mark to the right, 1 mile has already elapsed before this piece kicks in. That's a horizontal shift to the right. Yay, yes, use transformations. Now, the other thing to keep in mind though, all right, once again, imagine it's a 5-mile cab ride. 4 of the miles will be charged at this new rate. Notice 5 minus 1 is 4. Yes, makes sense. 4 of those miles will be charged at this rate. But the $3, didn't you kind of already pay $3? Yes, you did. So that is also in your total cost of the cab ride. So if you're picturing this graphically, the entire first mile is just a flat $3. But now that you've driven your first mile at the flat $3, it's now going to go up from there. So if you're imagining this piece of the function, this ordered pair where it switches from piece 1 to piece 2 is at the ordered pair 1, 3. 1 mile in, you've already paid $3, and now the new piece is about to begin. So you can use that 1, 3 to help you with your transformations, because once again, this piece does not start until 1, 3. So I'm really going to be leveraging the idea of transformations in this unit, because not only do they help you write functions when you're given the graph, but they also help you write functions given the context. You have to be able to imagine when one piece kicks in and the other piece is over. And if you know the ordered pair where the one piece kicks in, you can use that ordered pair to use transformations. So that particular pink piece is only valid if you're going over a mile all the way up to and including the 15th mile. That's when that rate, that piece would be valid for. Now, the third one, we're going to leverage the idea once again of transformations. The third piece, after you've driven the 15 miles, of course, it drops to just a rate of $1 per mile. So the slope now is just $1 per mile. But, yeah, I'm going to do it again. But that piece does not kick in unless you've driven 15 miles. So let me extend this for a second. It's not going to be drawn to scale, so don't judge me here. But that middle piece is valid all the way up until the 15th mile. So let's imagine for a second that you're having to take a cab ride that's 20 miles. 20 miles. Okay. So of those 20 miles, only 5 of them is going to be charged at this new rate. Only 5 of them. Think about that for a second. A 20-mile cab ride. One of those miles is the flat rate of $3. 14 of those miles will be at the $1.50 rate. And then the last 5 of those miles would be at this new rate. So if you are indeed traveling 20 miles in this cab, only 5 of them are at this new slope. And oops, that's because if you think about the transformation, that is because this piece does not kick in until those 15 miles are done. This ordered pair up here is kicking in at the 15th mark, shifting it to the right 15 miles. You won't even see this piece of the function unless you're 15 miles into your trip. So you're going to shift the piece 15 units to the right. M minus 15 would shift it 15 units to the right. Now, what about that? How much money would you have paid by now? Like this dollar, or not this dollar, sorry, this point up here, yes, it kicks in at 15, but 15 comma what? How much money would you have paid by now? Well, you would have paid $3, right? Already, but then you also would have paid whatever the other 14 miles are worth. Okay, so how do you handle this? The way that you handle it, ladies and gents, is you go back to the piece that you just left off on. Let me grab a new color. You go back to the piece that you just left off on, and you figure out where that piece ends. Where does that middle piece end? It ends at the 15th mile. So 1.5, 15 miles, only 14 of which would be charged the $1.50, plus of course the $3 that you already paid. So $1.50 per mile for 14 miles worth of travel, plus the $3 from the beginning. So 1.5 times 4, let me think, mental math, 14, 7, so 21 plus 3. By the time this third piece would have kicked in, you would have already paid 24 bucks, 3 of which were for your first mile, 21 of which were for the other 14 miles charged at the $1.50 per mile rate. So all in all, that little meter on the cab, you don't know what I'm talking about, do you? There used to be a meter, okay? Trust me, there was a meter. And the meter on the cab would have said, hey, your trip is already costing you 24 bucks. So back to my little graph, that ordered pair where the green graph kicks in is at 15,24. That is wildly smushed. And for that, I apologize, my friends. I can't change the size of my screen while I'm in the middle of a Zoom call. Darn it, sorry. 15,24. That green dot is at 15,24. Why is that important? Because come back down here to your function. 15 units to the right, but also 24 units up. That's the transformation of that function that tells you, hey, this piece of the formula doesn't even kick in until 15 miles into my trip. Shift it to the right 15 units. Oh, and by the way, I've already paid $24. Shift it up, 24 units. That is the ordered pair where that piece starts. Transformation of functions, people. Use it to your advantage. Now, that particular piece, of course, is only valid if we have traveled more than 15 miles. And this particular company only lets me go up to the 40th mile. So that, ladies and gents, would be the piecewise function for this context. Now, just to kind of plant a seed, if for whatever reason you then had like a fourth piece to write, okay, humor me for a second. If you had a fourth piece to now go take care of, so to speak, the way that you would get the ordered pair to use in your translation for the function would be to take the 40 then, because now you're picking up and leaving off at a new place. So you would have to take the 40 because that's your new transition point, so to speak. You'd have to take the 40 and plug it in to get the ordered pair if you needed to for your next piece. So the same way that I plugged 15 in to know that my vertical shift had to be 24. Well, if there was another piece to this, I would plug 40 in to that formula to know where that piece leaves off. Because again, I know the piece starts at 15. That particular piece starts at 15, but where does it end? You know, that's the question. When you're picking up and leaving off, so to speak, so you end one piece, start a new piece, what you're looking for is the transition point. So you'll always have to acknowledge where the starting and the ending points are. And the way that you can get the starting and the ending points is by simply plugging that end point in, and then you'll know exactly where it leaves off. So I don't think we have anything more than 3 pieces in our contexts, but just in case you ever had to go through those motions more than once, that's how you would handle it. So admittedly, ladies and gents, word problems for Piecewise, I mean, they're probably the hardest. I would say probably writing functions is from word problems and also from graphs are the ones that I think students struggle with the most. So what I would say to you is most definitely try to absolutely make sense of everything in this video. Don't just go through the motions and write down whatever I wrote down, but like truly try to wrap your brain around not only what each piece represents contextually, but also where those values come from. I'm telling you, if you can connect this to transformation of functions, that right there is the money. the moneymaker. If you can make sense of it with regards to transformations, you're going to be in business. If you're floundering and feeling like you're picking points off of a tree, it's probably not going to end well. So try to make sense of it. Obviously, we have more examples, and even if you feel like you're making a ton of mistakes, again, be kind to yourself. Come see me for office hours. Go to our tutoring center. I, of course, will be posting my answer keys always, and so you can see not only what the right answers were, but how I got them. I try to show as much work as I can, and hopefully that's helpful. So thank you for your time, and we will continue to be in touch. All right, thanks, guys.